Hello everyone. In today's lecture, we are going to see image sensing and acquisition. Before learning image sensing, let us recall what image acquisition means. Image acquisition is the first step in digital image processing. It is the process of converting a real world scene into a digital image that computer can understand. If image acquisition is not done properly, no amount of processing later can give a correct results. Human and doctors depend heavily on visual information, but human vision has limitations. We cannot see inside the body in low light or at microscopic levels. Medical diagnosis requires images that are accurate, repeatable, and objective. Image sensing allows machines to capture biological signals that human eyes cannot see. For example, MRI shows the brain, X-ray shows the bone, and ultrasound shows the internal organs. So, image processing extends the human vision. The key question here is how do we convert real world physical information in one digital image? Image sensing and acquisition involves three main steps. First, energy such as light, X-ray or ultrasound is captured. Second, this energy is converted into an electrical signal. Third, the signal is digitized into pixel values. The core components involved are the sensor, energy source and the digitizer. This slide prepares us to understand the different ways of image can be sensed and acquired. Depending on the application, image acquisition can be done using different sensor arrangements. In the next slides, we will see how different sensing methods are used in real systems, especially in biomedical imaging. There are many ways to sense the image. We can use a single sensor with scanning sensor arrays like cameras and multi-spectral sensing. Different technologies are used to such as CCD and CMOS cameras and X-ray detectors, ultrasound transducers and MRI sensor. Each method is selected based on the resolution, speed and application requirements. The physical sensing device is the heart of an image acquisition. It is the sensitive to a specific band of electromagnetic energy. It converts the sensitive energy into an electrical signal. The output signal is proportional to the intensity of the energy received. Examples include CCD and CMOS sensors in cameras, X-ray detector in radiography and ultrasound sensors. The digitizer converts the electrical signal into a digital form. It performs two important operations, sampling and quantization. This step converts a continuous signal into a discrete pixel values. Digitization allows the image to be stored, processed, and analyzed by a computer. Without digitization, digital image processing is not possible. The image acquisition process follows a clear sequence. First, an illumination source emits energy. This energy interacts with the object or a scene. The sensor captures the reflected or transmitted energy. An electrical signal is generated and then digitized. The final output is a digital image stored as a pixel values. Now that we understand the basic process, let us see the different methods used to sense and acquire images. These methods differ based on the number of sensors used, how motion is involved. In a single sensor image acquisition, only one sensing element is used. The sensor must move in both x and y directions to form a 2D dimensional image. This method gives high resolution and it low cost, but it's slow. Application include micro densitometers and flatbed scanners, and optical filters can be used to improve spectral selectivity. And sensor strips used sensor arranged in a single line, forming one-dimensional array. Motion prepares to the strip provides the second dimension, such as systems may contain thousands of sensors. This slide prepares us to move from linear sensing to most commonly used modern sensing method, which is sensor arrays. Sensor arrays consist of sensors arranged in a two-dimensional grid. This is the most common method used in modern digital cameras. No mechanical motion is required. CCD and CMOS arrays are widely used. Each sensor captures the integrated light energy falling on it, producing a pixel value. Sensor arrays can have very high resolution such as 4000 by 4000 elements or more. Higher resolutions give more detail, which is crucial in biomedical imaging. However, higher resolutions also increase the data set and processing requirements. To summarize, image sensing and acquisition convert real-world energy into digital images. Sensors capture energy, digitizer convert the signals into different sensing methods and used based on the application needs. This process forms the foundation of all image processing operations. And these are the references. Thank you.